All right, next part of the lesson, we're going to go back to some vocabulary. So discrete versus continuous relations. So discrete are going to be points that are not connected. Okay, so just a set of individual points here. So if we look at our example, this would be an example of a discrete relation. Or even in our previous problems, all of these are examples of discrete relations because they're just a list of points together. So they don't have anything to do with each other. They're just individual points. Continuous, then, is going to be when the domain has an infinite number of elements. So points can be connected with a line or a smooth curve. Okay? So typically our linear relations here, this would be one, or even if we have U shapes. So if it's continuous, so basically if you can take your pencil, put it down, and you can draw without picking up your pencil, that's going to be a continuous relation. Now the reason why we're mentioning this difference is because when we have these different types, one, we need to be able to tell if something like this is going to be a function or not. We also need to be able to tell what the domain and range is still going to be. So here with a list of points, it's easy. We just write down all the points. So like we did in this example, we just wrote down all the points and found our domain and range that way. Well, these two types of graphs, there's an infinite number of points, so we can't list all of those. So now the way we write domain and range is going to be a little bit different. So when it's a continuous graph like this, we're going to be using inequalities to describe our domain and range instead of just a list of numbers.